java.lang package is also having a class for mathematical operations. The class name is math, and it is having various mathematical operations, and all those are provided in the form of static methods, public static methods. So we can call all those methods by using just class name. Any method we can call using math dot the method name. So I have written a program demonstrating various methods of math class. See, these are the various methods in that class I am going to show you. Let us look at these methods one by one. I will be explaining them. See, the first method is absolute value method, right? Math.abs minus 123, it gives the positive value. Absolute value means positive value, so it gives 123. So if you are not sure whether the value is positive or negative and you want to confirm that you want the positive only, then you can use this method. So if you are receiving a value either positive or negative, it will give positive result only. So you may be getting a value from either from the keyboard or from a file or from any other source. Then that value you can confirm it as positive by giving it to this method. So let us check this method. I will make the rest of the code as comment, then I will run it so we can see only the result of this absolute. So I have one more absolute. I will explain about this one. First, let us run this. See, absolute value is 123 and this is also 123. So though the value was negative, so it has given positive value. There is one more class called strict math. We don't directly use this class, we use math class. This strict math class believes in giving perfect result. Perfect results. See, when you are working with float values, then we prefer getting more precise results. Means more number of digits after decimal. If we are looking for more precise results, then the time taken for computation may be more. So it may affect the performance. So basically, whatever the method you called from math, it will call the same method of strict math. So the strict math class is indirectly used through math class. Whether every method of math class will in turn call the similar method of strict math class may or may not be. So it depends on the JVM, the implementation of JVM. So implementation of JVM says that for performing mathematical operation, better call native method dependent on the machine. If Java want to do computation in its own way, then it may be a burden upon the device, right? The hardware. So that is the reason it is decided by the JVM. At that runtime, it is decided whether the method of the strict math will be called or math class is having its own method, own implementation, a simple method which calls local method, that is native methods of the environment. So finally, the bottom line is we use only math class. We may not be using strict math class. Okay, just I have given you introduction to strict math class also. We have finished absolute. Now we will look at next method. So I have commented rest of the code. I have only one method visible here, that is cube root. Cube root of 9. Let us check. It is 2.08. I will change this to 27. So cube root of 27 is 3. 3 into 3 into 3 is 27. So cube root of 27 is 3. So this is a cube root value. Let us look at more methods. Now next method is decrement exact. Decrement exact, the value is 7. So 7 will be decremented. So 7, when it is decremented, it is 6. Then what does it mean by decrement exact? First of all, let us run and check whether it gives 6 or what. Yes, it has given 6. Just look at this one, okay? Then what does it mean by decrement exact? So I will do one thing. I will take a minimum integer value. So when I take minimum integer value and try to decrement it, so it's the lowest value. When I still decrement it, then it should become a maximum integer value. So you know about overflow or underflow, right? So it will take a largest value, but decrement exact means what it will do. Let us check. See, it is giving arithmetic exception. So decrement exact means it will not change it to largest value. So I will show you. I will explain it more. See, watch here. I have a variable I, which is having a minimum value of an integer, min value of an integer. Okay. Then I will do I minus minus. Then let us print this one. See, look at this code. This is minimum value of an integer, I minus minus. Then I am printing I. I will comment this one because this is giving exception. Let us see what happens to I. We'll do one thing. Without decrementing, I will show you minimum value. Just minimum value. Integer minimum value is printed. So let us check what is the minimum value. -2147483648, right? This is the minimum value. Then next, if I decrement it, then what happens? After decrementing, if I print, then what happens? Let us see. It gives positive value 2147483647. This is the integer maximum value. So the number has underflown and we got the largest value, right? So, but it will not happen here when you say decrement exact. So you can make sure that the decrement is having perfectly. If not possible, it will throw an exception, means it will not decrement it. All right. So this is decrement exact. So it will prevent a number to get underflow. That's all. This is over. Now next, this one. Exponent value in float point representation. Get exponent. See, this 12.3456 is not stored as it is. It is stored in Mantisign exponent form. It is stored in Mantisign exponent form in main memory, right? So Mantisign exponent, you will get the exponent value. All right. So how exactly it is stored inside the memory? From that we get just the exponent value. Exponent value is 10 power, whatever the exponent value is, whatever the power of 10, we get that one. So for this number, it is giving the result as 3. The exponent is 3. I will change the number and show you. I will just take 12. Let us see what happens. Exponent is still 3. So it is taking up to 3. So if I change it to 123.45. Now let us check. It is 6. So this representation, if you want to study Mantisign exponent, you can explore it, right? So if you have the idea what is the floating point representation, then you can understand this perfectly and use it. So if at all your application requires a lot of floating point computations and you are dependent on this exponent value, then you can use this one. So you need to study on this one further. Let us look at other methods. Next method is floor div. So 50 divided by 9. 9 5s 45 and 5 is remainder. So 5 point something we get. 5 point something, right? But it will give floor of the division. Floor of the division means it will give the truncated result. So it will remove the decimal part. Let us check. So it should be 5.5 something, but it has given just 5. So floor of division. So it is more like integer division. Then this is a exponent e power x. So e power x of 1, and this is again I am using strict math and finding e power x. So this is a math class method exp, and this is a strict math class method exp. For both I have given 1. Check the results. See, this is the result from math class and this is the method result from strict math class. So this shows that math class method is not internally using exp of strict math class, because a strict math class result is different, 1 digit extra. So I told you in the beginning, math may or may not use, but mostly we believe that Math class methods use the methods of strict math, but here it is not using. This is one of the example. It means that math class is having its own way of computing it by using native methods. So it is not using Java way of calculating the results. Let us look at other methods. See, this is the log value, log base 10. 100 log base 10 means 10 square is 100, 10 square. So power will be 2. So the result of this will be 2. If I give 1000, then it will be 3. So log base 10 we get. And if just log is also there, one more method, that will be a natural log, log base e it will be. Then this is maximum of two numbers. You can find out maximum two numbers. So max method is there. For likewise, you have minimum also. So you have max and min methods. You can use them. Then this is for trigonometric function, that is math. So this method will take radian value. It will not take degrees. Usually when we learn trigonometry, we use degrees, right? So we are familiar with degrees, but this method takes radians. So for 45 degrees, tan 45 is 1. So we have to give radians. So for converting degrees into radians, we have to multiply it with pi by 180. So I am multiplying it with pi by 180. Pi value I am taking from math class only. Okay. So this will give radians. So let us check what is the result. Yes, it is not exactly 1, you can see 0.99999. Yes, computation on floating numbers may not give you exact value, they will give precise values. The more number of 9 makes it more closer to 1. So we know it is 1, but we don't get 1. So you have to either seal it or floor it. So whatever you want, you can do that depending on the requirement. Next method is radians. So from degrees you can get radians. And one more method is arctan, that is inverse function of tan. Okay, tan 45 is 1. So arctan of 1 is 45. 45 it will not give 45, it will give radians. So I am converting it to degrees, 2 degrees. So radians converted to degrees. Here degrees converted to radians. Here degrees converted to radians. Okay. The next hyperbolic tan also I am calling. So just let us run this one and check. See, radians of 90 degrees is 1.5 and this is arctan, it is 45. For 45 it is 1. So for 1, inverse of 1 is what? 45. Tan inverse. This is tan inverse. Arctan is a tan inverse. Okay. So let us look at other methods. This is a random method. It gives a random number between 0 to 1. Means it will give a float number. So if you want to make it integer, multiply it by anything like 10 or 100 or how many digits you want, you can multiply it with that number. Like suppose I want a 3-digit number, then multiply it by 1000. So we get 3-digit number. Then next is power method is there. So it will find out the power to power 3. Okay. Then multiply exact. So multiply exact means when you multiply two numbers, the result may go beyond the capacity of integer or any other data type, right? So if we take integer, the result may go beyond the capacity of integer. So it will give overflow results. So the result may become negative. Exact multiply means if the result is within a range, then it gives you the result. Otherwise, it throws arithmetic exception. This is exact multiply. Then next method is next after. So 12.5 is given here, so it will give the next float number after 12.5. So here 13 is given, so it will go into this direction towards 13. Let us check. See, the first is random number is given, 3-digit random number. After decimal you can truncate. Okay, actually it has given a float number. Next is power of 2 power 3 is 8, and this product of that is 100 and 200 is 20,000. And this is next float is 2.500002. This is the next float number. So that's it. We got the result of all these. Now one more thing I will show you here. See, I have written 12.5 and this is 13. So it is going towards 13, I said, right? So going towards 13 means next number after 12.5, because 13 is given here. So if I change the number and make it smaller number 11, then it will give next number. So next number not after 5. before 5 because we are going towards a smaller number. So it will give a next float number in the backward direction because the next value is 11. So backward direction means it will be 12.4 something. Let us check. See, 12.4999998. So this is actually a previous number. Okay, it's not a next number, it is a previous number. So the method name is next after only, but depending on this value it will give either next number or previous number. If you give greater value, it will give you the next number. If you give smaller value here, then it will give previous number. So that's all. These are some interesting methods of math class. Actually, I have explored all of them. Rest of the methods are there. You will find them similar only. Like there are overloaded methods and all. So if you explore the math class, you can understand all the methods. So that's all about math class. You also explore it once.